Let me present our speaker, Kate Marshalkina. She is a seasoned full-stack developer and engineering mentor with more than 15 years of experience building scalable products and guiding developers in their journey. She is obsessed with regular expressions, books, and web technologies. In her work, she mixes old with new, soft with hard, cats with dogs. When it's not a disaster, it's pure magic. It's an honor to have you here with us today, Kate. The stage is yours.
Thank you. Thank you so much for having me today. Of course, to answer the obvious question that all of you have right now, this is the mix of cats and dogs that Violina mentioned. But actually, today I wanted to discuss a rather tricky question. Is testing easy in 2025, right? We mentioned AI technologies, we mentioned all this innovation. Is testing easy? And before we jump into the topic, can you please drop a message in chat if you worked with Playwright before? You can just say yes or plus sign or thumbs up, whatever, or minus if you haven't worked with Playwright, just so I understand the audience. Let me go to the chat real quick. I think I lost it, sorry. Here it is. Okay. Just reading your messages. All right, so a few people say that haven't worked with Playwright. We started using it at work about a year ago. Great. So we have a mix of people. Let's then start with, once I figure out the Zoom situation, let's start with a quick introduction to Playwright. Playwright is a popular end-to-end testing tool. What does it mean? It means that it helps you automate interactions that a real user performs in a real browser. It's very easy to install with just one command. You get default configuration, browsers, because Playwright runs tests in the browser, an example test, and even GitHub action workflow so that you can configure your CI/CD pipeline. It comes with CodeGen. It allows you to record tests without writing any code at all. Basically, you click around your website in a browser and you get back simple but functioning test code. When you have more advanced test scenarios, Playwright has all the features. Visual comparisons. You can kind of, in your test, take a screenshot of a page or part of the page and then compare it with the previous screenshot. Snapshots. You can compare blobs of text or accessibility snapshots, API testing of your REST endpoints, even Chrome extensions testing, components testing. It's available in multiple programming languages. When tests inevitably fail, Playwright offers best-in-class developer experience with built-in debugger, VS Code extension, screenshots, reports, videos, and my favorite, the trace viewer. The trace viewer is a one-stop shop for any Playwright test failure. It provides all the test steps along with screenshots, errors, console logs, network requests, and basically everything that we usually check in the browser DevTools. The mandatory AI slide. Playwright offers a couple of AI features. One is copy error as prompt, or I think now it's renamed to fix with AI when the test fails, and also Playwright MCP server to help LLMs, large language models, to communicate with Playwright APIs. Let me show you a quick demo. I attended a React Summit a couple weeks ago, and I wanted to write a review blog post. So I asked Cursor, the editor, to write it for me with the help of Playwright MCP. cursor asks Playwright MCP to fetch a conference agenda from a website. Playwright returns an accessibility snapshot, something that is very easy for LLM to digest. And as a result, cursor writes a decent first draft of my blog post. That's very cool, but of course, the main purpose of a Playwright is to help us write reliable deterministic tests. And Playwright is a very practical tool in this sense. It comes with auto-weighting and web-first assertions. Authentication and multi-user support comes out of the box, the same with parallelism and sharding. Finally, it has great community that provides community plugins, best practices, and integration with other tools. All in all, Playwright checks all the boxes to make testing easy. At least this is what I thought when a year ago I joined a team at ATO, a healthcare analytics company that offers a range of products for data scientists in the healthcare sector. It's a highly specialized and regulated business domain that probably has acronyms for pretty much everything in the world. Let me give you an example. In the International Classification of Diseases, it's a real thing, there is a code W6162XD that means, it literally means struck by duck subsequent encounter. And with such a specialized and precise business domain, our team was asked to cover all the major features with automated tests for regulation purposes. The scope included 64 epics of tests. For a non-professional like me, the UI looked like gazillion checkboxes, acronyms, tables with random numbers all around, all that powered by 5-year-old React application and 10-year-old Java backend. The backend had its own journey from monolith to microservices back to monolith, leaving us with a bunch of outdated legacy API endpoints, but that's not for now. For now, let's focus on React. As the product evolved, some of the components have grown over 1,000 lines of code with those huge use effects, with missing dependencies and dependency array and all that stuff. React version 17, so 2 versions behind. Most of the code untyped. ESLint and Prettier got lost during cloud migration. And our first reaction to this project can be very well summarized by my teammate, who said this code is impossible to test. Or, speaking scientific language, R45.4, irritability and anger. Challenge was not accepted. With all those excuses running in my head, no, it's not my job. Even a junior developer can do that. Even AI can do that. And after prompting ChatGPT for 5 hours, stupid AI, it will never take my job. And after all of those thoughts and excuses, finally, I decided, okay, I'll write the tests. But where do I start? What kind of tests do we write? We needed a testing strategy. And now I'll pause here just to check with you. What do you understand by testing strategy? Have you ever worked with any kind of testing strategy? What comes to your mind when you hear these words? Just to check with you, and then we will continue. Let me see if I can open the chat. Yes, I can. All right. Just keep, let me just close this thing real quick. Zoom is fighting with me. Just keep using the chat if you have any thoughts or questions, and I will continue with the testing strategy theoretical block. Probably the most popular testing strategy out there is the testing pyramid. It promotes breaking software into smaller testable units. Honestly, not our case with our state of code base. Another option we had is the reverse testing pyramid, basically putting the pyramid upside down. If we put a bit of ice cream on top, then we get the default testing strategy for many companies, the testing ice cream cone. Most of the testing is manual, and only some of that gets automated. Not that tasty. Yet another option is the testing diamond. It puts the main focus on integration tests. An evolution of the testing diamond that is more popular in the front-end community is the testing trophy by Ken C. Dodds. It clarifies what different types of tests mean in the context of the modern JavaScript ecosystem, and also makes static checks such as ESLint and TypeScript more explicit. Not everyone knows, but Ken's favorite testing shape is the testing Dorito by Tim Myers. Let me read it for you from top to bottom. Tests I plan to write, tests I start writing, tests I delete because I decide they're stupid and take more time than they're worth, and finally, tests. And yeah, it may look funny, but it's a good reminder that theory and practice don't always have perfect match. So without further ado, let me introduce the brand new testing strategy, the testing mushroom. The cup of the mushroom is all about end-to-end tests. They clear regulation requirements and also help us build a safety net so that we start refactoring and introducing integration and unit tests. The testing mushroom is a growing organism, so it's expected to change its shape as we learn more. Now, with this great testing strategy, we were ready to go, so it was time to execute. The whole team sat down to write as many tests as possible, as fast as possible. And a month later, it didn't work. It was a disaster. The more tests we were writing, the more of them were failing with all the random reasons, and it was impossible to figure out what was going on. It was a time for emergency action, as I call it, namely reading documentation. At least the best practices part. Apparently, most of our tests were flaky because we misused Playwright API. Here I have an example. The line at the top is the wrong way to use Playwright, and the line below is the right way to check the welcome text on screen. Both work, it's just the first one sometimes randomly fails. And to be honest, the difference is subtle, especially when you review thousands of lines of test code. Luckily, the solution was simple. We installed ESLint plugin Playwright. It helped us fix all the issues and also to learn what was the right way to use Playwright. With that, we continued, and 2 months into the project, we realized that we were behind schedule. So we had to ask our colleagues from other teams for help. And this is when we faced our next challenge, test dependencies. As you remember, we're dealing with quite complex business domain. A typical user journey can take several minutes before achieving some meaningful results. And for a developer, it's tempting to reuse results from previous tests and build new tests on top of them. Unfortunately, it breaks test retries and makes local debugging practically impossible. You never know in which order and which tests to run. Once again, we decided to check the best practices, and one of them says, make tests as isolated as possible. Easy to say, hard to do. we had to enforce it with full parallel mode and increase the number of workers to 3 so that we actually run tests in parallel. It revealed a few issues, we fixed them, and after that, finally, we were green. Our tests became much more stable, and they started catching real bugs. Let's check what's wrong with that item in the top right corner. All right, that's my test. I wrote it, and I immediately see what's wrong with it. It's one of the backend APIs not returning the correct response, so I'm pushing this issue to the backend team. The backend team opens it, apparently in the dark theme, can't understand anything, probably just like you, and push it back to us. And we push it back to them, and so on and so forth. That's 63.1, problems in relationship with in-laws. Apparently, our test reports were not readable at all, and we had to improve it. When it comes to making code more readable, we already know how to do that. We break it down into smaller logical pieces. In testing, there is a common pattern, page object model, where you organize your tests in classes per page or per screen. Here, for example, I have login page class, and it contains all the actions that can be performed on that page: login, logout, password reset, etc. We already had our code organized this way, and apparently we were just one step away from making our test reports as readable. And when I say one step, I literally mean it with the step decorator. The step decorator groups lower level Playwright actions in higher level logical steps that are much more readable. The step decorator is not available out of the box, but there is documentation how you can configure it for your use case. With that, our test reports became much more readable, even for our lovely backend team. If I zoom out a little bit, this is how the failed test looks in the report. It contains all the steps along with tags, history, retries, screenshots, videos, traces, and all the stuff comes from Allure Reports. Allure Reports is an open source, cross-language, cross-framework test reporting tool that helps even non-technical users read the tests and make sense of them. As usual, it's very easy to configure it to work with Playwright. Cool. Finally, with that, we were on the finish line when suddenly our platform engineering team reached out with a much bigger problem. And I'll pause again here to ask you, do you have an idea what was the problem that platform engineering raised and what was so crucial? Let me fight with Zoom again. Zoom. Uh-huh. Not yet. No ideas yet. What could go wrong with the tests? They're so great. The platform engineering team is likely just not understanding things, right? Okay, let me show you something. Give me a second fighting with Zoom. Here we go. So, as a reminder, we are running tests in 3 parallel workers in full parallel mode. And this is extremely slow. It was taking around 1 hour to run the tests. And if you also want to run them multiple times, it could block the deployment pipeline for an hour or 2, which was not acceptable. The tests were slow. Now, with just one change, we went from 51 to 17 minutes. Yes, we just increased the number of workers. You can see at the beginning of this visualization, this is, by the way, again, a little report visualization that shows how exactly the tests are distributed across workers. This white space is the room for improvement, but in general, it was already a good first step. Now, this, of course, doesn't make each individual test run faster. You just run more of them in parallel. If we compare end-to-end tests with integration tests are usually much faster because they skip or mock expensive operations. In Playwright, we have network API for intercepting HTTP requests. And in one of my previous projects, we mocked all HTTP requests. Our tests were super fast, super green, but they never caught a single bug. Instead, we were constantly regenerating and updating mocks. So I'm not a huge fan of this kind of approach. Could we gain similar performance boost, but without actually maintaining mocks? Mocking without mocks, as I call it. And this is exactly what Playwright Network Cache plugin offers. Let me show you how it works. Imagine we have 5 slow tests. Each starts by performing some slow operation that takes, let's say, 5 seconds. Let's say opening a test project. With Playwright Network Cache plugin, where a first test will perform the operation and save the result on disk as cache. Doesn't matter if that operation was get or post HTTP request 1 or multiple. Then all the other tests will use that cache as mocks. In our case, we actually had 200 such tests, and it gave us 10 minutes of test running time immediately. That's insane, but it's also kind of cheating because it's no longer pure end-to-end tests with mocking. And that's why in the testing mushroom, integration tests sit inside the mushroom cup. They're kind of mix of both. And I could talk more and more about testing mushroom because it's just so much fun. But honestly, I made it up completely for the purposes of this talk to illustrate the approach that we took for this particular project. And your approach will be different. I hope the testing mushroom inspires you to explore all the different shapes and strategies out there and find what works for you and makes testing, if not easy, then at least more fun. And with that, let me recap. We wrote all the tests, mission complete. They are stable and readable. They catch real bugs. They run in full parallel mode. Great job to the team. But there is something else that I didn't mention, an unexpected side effect. Today, a year later, we have React and other major libraries upgraded. We deprecated those outdated integration tests with legacy mocks that nobody could maintain. The team switched to monorepo to improve development experience. We migrated to feature-slice design code structure to align better with our business domain and also to start breaking code into smaller testable units. It accelerated TypeScript migration, and all that made development of new features easier. Today, 1 year later, it's a completely different code base, but I know it all started with testing. So back to the question, is testing easy? It depends on the right strategy, discipline, and skill. But good news is that everything else becomes easier when you've got your testing right. My name is Kate. I'm Collabor in all social media. Thank you very much. Happy testing, and I'm opening for your questions.
Thank you for the great session, Kate. It's really impressive how your team work improved for a year. Everyone who is joined the meeting and have questions to Kate can send it in the chat or unmute. She'll be happy to answer.
I have a question. Kate, the session was amazing and very informative. I also love the way how you approach us with sharing the fun facts and the pyramid. So for someone who haven't used this before and they're not familiar with it, what is the first steps? What's the documentation or resources you can recommend?
I think Playwright is actually a good tool for someone who haven't approached tests, especially in front-end area. I would recommend just going to Playwright official documentation or asking your favorite LLM. AI is usually very good at first steps. It becomes trickier when you dig deeper, but very first step, I'm pretty sure it can help you with. The official documentation usually recommends to start with just one test. Imagine you have a huge, complex application, you're overwhelmed. Where to start? I need to write 1,000 lines of code. Don't think about it. Just go and write one simple test that just goes to the homepage and checks, I don't know, the heading or something like that. Start with that, and everything else will continue from that. Maybe you will not like it, you will throw it away and go and choose a different framework, or maybe you will find it useful and slowly it will evolve. So start with one small test.
Thank you so much.
I have a question. If there is anything you could change now when you have the experience after 1 year, could you, or what could be your approach if you should start now?
At the beginning, we wasted quite a lot of time trying to optimize things. So we were worried about wrong problems. We were worried, we have code repetition, or we have, basically we were worried a lot about repetition. We wanted to optimize our tests so that we don't do the same thing twice, like we don't do registration twice, we don't create certain things twice, etc., etc., because it just felt wrong from, traditional development perspective. But in testing, isolation was much more important. So if I could change our approach, I would go to myself in the past and say, okay, don't worry about that. Worry about isolated tests. It's fine that they repeat themselves in some areas. That's not a problem, because it's much more important to make reliable and stable tests than having the fastest, the cleanest code possible, because the goal is different when you're testing.
It's very important. Thanks for sharing. Maria is asking, what's the most surprising book Playwright helped you uncover?
That's a good question. It helped me to uncover so many bugs. So we started writing tests. Our front-end team started writing tests, primarily focusing on front-end functionality. But most of the bugs that we discovered were back-end bugs. And most of them were very surprising, because when you just normally use application, everything kind of works, or you don't notice that it works slightly differently. And when you automate the process, suddenly you see those little things. Oh, yeah, I don't remember the good example. Like, for example, just one recent one was let's say you create a new configuration and you give it a name. And then you edit this configuration, which is apparently not something that users often do, but when you edit it, suddenly you start editing the wrong configuration, the previous one. So imagine you have configuration 1, configuration 2. You want to edit configuration 2, but instead you're editing configuration 1 and you don't know about that, because there's no indication of that. So that's quite a tricky thing. but that was the case.
For the answer. Another question. Any testing myths you would like to debunk based on your experience?
Can you give an example of a myth? For example, the testing pyramid, right? There are people who think that it is the only way you should test with the testing pyramid approach. Then you heavily invest in unit tests, and everything else is wrong. In my practice, it's not the case. Indeed, testing pyramid is a good practice and good approach for certain code bases, maybe for a lot of them, but not for all of them. For some of them, the testing trophy is the best approach. For others, the mushroom, the Dorito, etc. So this kind of focus on one and only one strategy is limiting. I don't know if it's a myth or just the lack of, experience, but it happens that you just read about one particular thing, one particular technique, and you think that it's the only one. No, it's not the case. You have to explore and build your own opinion. The other one is TDD. Probably it's a very hot topic for any developer. I think TDD, test-driven development, a very particular practice where you go red, so you write a test that fails, then you go green, you write minimal amount of code to make the test pass, and then you refactor. So you keep the test green, but you improve the code, and you only allow to work in this kind of cycles. Again, it's a very cool practice, but it's not a silver bullet for all the kind of problems and types of coding that we have. I personally can't do TDD. I don't have enough skill. It's a skill issue, and I work on it when I have opportunity, because I think the skill aspect is kind of underestimated. Maybe it's another myth that the testing is easy. It's not easy if you don't have skill. Just asking ChatGPT to generate ton of lines of code, test code for you, will not give you that skill. You have to suffer a little bit figuring out why this test is good. Does it bring value? Does it actually catch bugs? Why this piece of code is hard to test. So you might catch yourself feeling, I don't want to write tests. I want to delay that or something. It's interesting to stop and reflect a little bit what it is with your code that prevents you from smooth code writing. Is it lack of skill, lack of tooling, or is it the code structure, the architecture of your code that prevents that? So yeah, practice is king.
Thank you, that's great advice. Honestly, I try to write tests with ChatGPT and they always fails. And plus I get to the point that it's easier to write the tests myself than use AI. We have another question. What's your team's approach to organizing large test suites in Playwright?
We heavily use tags and labels. I had a slide where you could see the tag. Maybe I can share it again. Give me a sec. Here we are. Sharing my screen. So this is the example of the test itself, and you can see the tag PE689 probably doesn't mean a lot to you, but means something to our system. It's basically an epic, and you can have as many tags as you want. And then you in the sidebar, you can see there's categories, suits, graphs. So with those tags and labels, you can organize tests in those, basically categorize them in groups, so that you know, okay, this suite is dedicated to, I don't know, homepage. This is dedicated to personal account, etc., etc. They also offer search interface, so you can just type the number of the ticket, epic, or just name of test, and you can find quickly what you are looking for. We also had to enforce this system because it was a bit of Wild West. Everyone would put any random thing in the tag. Oh, it's, I don't know, bug fix, something like that, and it was not useful. So we came up with standard list of tags and standard way how to extend this list in TypeScript. And you are only allowed to add tags from this maintained list of tags. So no rocket science, just like you organize your notes, I don't know, or files, the same way you can organize the tests.
Thank you. That's good advice. I don't see more questions in the chat. Thank you so much for the great session, Kate. And definitely it's good to see how Playwright can help in practical example, because we usually see some experiments, but that was very good that you talk from your experience. And the session is very helpful, interesting, and interactive. And
Thank you very much.
try the mushroom strategy.
Thank you very much. It was a pleasure. Enjoying happy testing.
Thank you, Kate. Amazing session.